Trigonometry in 3D space should be called. In this lesson, we're going to be given a 3D figure with points and coordinates instead of like a 3D figure with just like the size already labeled to you. Now we're going to have a 3D figure in 3D space, so you have to find out the length of the side yourself using coordinate mathematics. So that's the difference. So look at the first one. Find the angle between the line segment EC. So we're talking about the line segment E. E starts here, C ends right there. So if I was connecting those two, it'd be right there. Hoping to make a straight line for me. And the base of the plane ABCO. So that's the base of the plane A. Right here's A, B, C, O. So the base of the plane right here. Remember, O is the origin always. So remember the way we did that before? It's when you try to do a line like that, it's the base of the plane, it's a projection. So you go straight down and draw that line that connects it. So something like this. And this is the angle I'm looking for. And that's the triangle we're making. And since it's right there at the edge, that does make a right angle. So we have like a right angle where this is E, A, and C. And this is the angle we're looking for. Now, any context views you use will make our life easier. Since this is a 3D model or 3D graph here, I could do stuff like find this height or find out what this point is. Right? We went 5 on our x, and then what did we go here to get to E? We went up 3. So we went 5 this way, and then up 3 this way. So this right here is 3 because that's how far we went up. By the way, if we want this point E, it would be 5 to the left, and then 3 up, and then 0 on our y. So this will be with the point 530. Now, I have one side and I have an angle here, so all I need is another side. It could be this one, it could be this one, doesn't matter. How do we find the length of something in 3D space? We use the distance formula. Now, I'm just going to do, but let's do the bottom one, I guess. Because I have those 2 points. I mean, I have this point now here too, but I guess I'll just do the bottom because I said so. Right, so here's the bottom. That's point A and point C. We're going to use the distance formula. Our distance formula is x, let's call this x1, y1, z1, and x2, y2, z2. So it's just going to be x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared. Then I'm going to get 25, this is negative 5 squared, plus 16 plus 0. So we're going to get radical 41. So this base here is radical 41. So, since it's a right triangle, I can use SOHCAHTOA to solve this. And we have the opposites of my angle and the adjacent of my angle. So TOA. So tan with theta equals 3 over radical 41. Take the arctan of both sides. And theta would equal, need a calculator for that. So turn this on. Inverse tan of 3 divided by radical 41. 25.1. So there we go. Next one. So they give us this big picture. State the coordinates of M. So we want the coordinates of M. So this looks like the midpoint. I'm guessing that's the midpoint of A and D. Yeah, it is the midpoint. They give the little congruent signs here. So it's the midpoint of A and D. Now if I want to find the midpoint, I just use midpoint form. But I don't have the value for D yet. So we got to find that. So how do we do that? We just got to get there. So how do we get there? Well, I imagine we get there by starting on our X. So we go back this way. And it looks like we went back negative 8. Right? And then I would go probably either go mid to right here, midway, because it's the halfway mark. Like that. Well, if this is 6, halfway would be 3. So we went 3 in our Y. Now notice this, our X was negative because we went to the back. Remember, normal X goes this way. Going back is a negative X. The normal Y goes right, so going back would be a negative Y. So we went forward, so positive 3. And then we have to go up to D. Well, remember, up is positive, and how far did we go? According to this, we went 5. So it's negative 8, 5, 3, and 5. Like that. And you could also tell we went 3 this way because this value has 3 into 5. So really the only thing that's going to change in the midpoint is the x value. Everything else is going to stay the same. But if we want to do the midpoint, we can just do the formula, which is point of A, which is this one, and the point D, which is that one. So out of the x value, 0 plus negative 8 divided by 2. The y value is 3 plus 3 divided by 2. And this is m. The z value is 5 plus 5 divided by 2. So we get negative 8 divided by 2, 6 divided by 2, and 10 divided by 2. So we get the point negative 4, 3, and 5. That's the value of m. So like that. Find the angle between the following line segments and the base of the plane, AE. So let me erase some of this so it's not in the way. AE. So from A to E. So this one. Then remember, you always go and draw the vertical projection down to hit this guy. Again, that'll make a right angle. So you have that. And again, just kind of the one we did earlier. I know the height of this already. It's 5, right? As we go from 0, my z is 0 on this line here, and then now we go up 5 until right there. So all I gotta do is, since the right triangle, all I gotta do is find one of these two sides. And normally I would use, I don't know, the base, I guess, E to this thing, but I don't know what point this is. I can find it really easily, but don't need to. I have this side. So I use this point, 0, 3, 5. I need the point of E. Now they don't give me the point of E, but we can find it fairly easily. All we gotta do is trace our steps to get to E. So how do I do that? So you wanna go your x first. Now do we go to positive or do we go negative? So let's have to go back negative on my x. Remember, that is 8 sets backwards. It tells you right there. And then I got to go from here. I got to go on my y to get to my e. And how far is that? It is 6 values on your y. So we have a point negative, 6, and then 0. Because we didn't move anything up or down. We stayed where we were. So that's how you get that point there. So you just follow. Okay, how do I get there? Go on my x, I go back 8, and then on my y, I went right 6. I get to the point. So now, since I have these 2 points, I can use the distance formula to find that distance. So to find AE, the distance formula, negative 8 minus 0 squared, plus 6 minus 3 squared, plus 0 minus 5 squared. So I get 8 squared, which is 64, 3 squared, which is 9, plus 5 squared, which is 25. So square root of that, to me 73 plus 20 is 103, 108. So this is square root of 108. And then, if I look at the right triangle and try to find that angle, it's just opposite over hypotenuse. So sine of theta equals 5 over radical 108. And then just use my calculator, inverse sine, 5 divided by radical 108. So about 28.8. So there we go with that one. B, I want to find MB. So I can erase some of this stuff. Okay. I want to find MB. So from M to B. So it's here to here. Now, so there's my line. Now remember, we got to go straight down, so it's a little hard to see. And then we got to get back to there. So again, this will be a right angle, a little hard to see there. And I know the height already, it's 5. And it'll be the same idea. I don't know what point this is. I went straight down. Probably can figure it out. I'm not going to know it right now. But I could find hypotenuse. Now again, this is a hard one to see. It looks like this. This is 5. This is my right angle, and this is this. Where my top point here is negative 4, 3, 5. My point down here is 0, 6, 0. Right, because this is my B, and then this is my M. So I get that. And again, all I need is that. If I have those 2 points, I could figure out what this is by the distance formula. So I was going to try to find out what MB is, and it's into the distance formula. So it's going to be -4 minus 0 squared plus 3 minus 6 squared plus 5 minus 0 squared. And I get 16 plus 9 plus 25. So almost the same as that one, but a little bit shorter. So I get radical 50. So that's my height, rad 50, or my hypotenuse. So, and again, just like last time, I have hypotenuse and I have a side, so this would be sine. Sine of theta, I guess, would be 5 over rad 50, which would get me let's change that to 50, delete the excess, hit enter, 45. Wow, 45 degree angle. So like that. So that angle there is 45 degrees. Interesting. So it means it's isosceles. That this, if we would have figured out this distance, it would have been 5 also. And then finally, I want me to find angle ABM. So ABM. So A to B, and B to M. Now B to M we found already. We found this part right there. That was rad 50. So exact same line, right? This is B, that's M, exact same line. I want to find this angle here. Now, again, I said before, we could use this to help us. I could connect these two. This makes that a right, because it is a rectangular prism, so all the sides, all the angles here are right angles, so that's a right angle. And I can figure out what this thing is, because we're on a 3D grid. We went from 0.35 to -4.35, so this is 4 across. Right, so again, right, to go from there to there, it's 4 across. You know, that marking just means they're congruent, so it doesn't mean like 1, 2, it's congruent. So the whole thing was 8. Divide that by 2, you get 4. Also, we went from 0 to -4, so this is 4. Notice it's not -4, it's the distance, it's just 4. Anyway, so right triangle, how do I solve it? Well, once again, we're using sine. We have opposite and hypotenuse. So to find angle ABM, it's going to be sine theta equals 4 over rad 50. Which was that the exact same one? Nope, last one was 5 over rad 50. So it's going to be a little different. So I'm going to get this answer again, and then change that 5 to a 4. We get about 34 degrees. 35 degrees, we'll say. 34.4. There we go. That's the lesson.